in Fourier series, right, or Fourier transform, for instance, any signal for that matter, first condition, I mean, like this condition also they ask in some of the competitive exam. So if I have signal, any signal, right? So it should be made of the orthogonal elements. Okay. So if I say that like x1 of t and x2 of t, so when do I say these both are orthogonal? Okay. So actually integration from t1 to t2, x1 of t into x2 of t dt should be 0. Then I can say these two signals are orthogonal. So in Fourier series, the orthogonality is a must condition to exist. I mean, the Fourier series to exist, right? The orthogonality is must. Okay.
Yes, sir.
So one of the most popular, there are like various type of Fourier series. So one of the most popular type of Fourier series is the trigonometric Fourier series. Fourier series. So x of t, any signal x of t, in terms of trigonometric Fourier series, I can represent it as a1 a naught cos omega naught t plus a1 cos omega naught t plus a2 cos omega naught t, so on. Okay. So whereas like omega naught, right? So that is a fundamental frequency. Okay. Omega naught is a fundamental frequency. Same way, like this is even term. Right? Same way we will have odd terms as well. So b naught sine omega naught t plus. Yeah. So here one thing I missed, omega naught. So 2 omega naught t, 3 omega naught t, so on. Okay. So here also a naught sine omega naught t plus sine a naught b naught sine 2 omega naught t, so on. So these are actually even terms and these are actually odd terms, and you also have DC terms. In the sense, as I said, like previously, any signal is made up of fundamental sines and cosines, and you will have some DC component. So this the DC component usually will be E naught. Okay, A naught will be DC component, and followed by you will have various odd and even terms, right? The even cos and sine. So that's the like this expression itself. If you see any signal for that matter, like if you take x of t, any signal, like it can be triangular, square, or sawtooth, any signal. So you can represent in terms of sine and cosine. I mean, if you had used, I'm not sure, like in your college, you had spectrum analyzer, right? So if you take the spectrum analyzer, so any signal you pass, right? So you will be seeing various frequencies. Uh, you will be seeing spikes at various frequencies. That is nothing but spike is nothing but it's a sinusoidal signal, right? I mean, you know the Fourier transform of sinusoidal signals, like plus one real time one delta of t, the imaginary term side one delta of t, right? So it's basically you will see series of such signals with the various amplitude. That is nothing but it is made up of such sinusoidal signals. So to generalize this, so if someone asks you like what is the Fourier series of any signal, so x of t equals to a naught, that is DC component, okay, DC component, plus sigma n equals to 1 to infinity. So a0 is already done here. 1, it should start from 1 now up to infinity, an cos n omega naught t plus bn sine n omega naught t. So this is a standard expression. So if you see this is DC and rest of the things are ACC.
Yes, sir.
Okay. And some of the important conditions, like in terms of Fourier series also you should remember. So I mean it will be like not only in terms of signals and systems, like from the math part also they will ask. So integration from 0 to t cos omega naught nt dt, and n is not equals to 0. So what is the equation equivalent for this is 0. Okay, so another condition, integration from 0 to t sin omega naught nt dt. What will be the value? Here also n not equals to 0. This also
Yes,
is
sir.
0. 0. Okay.
Yes, sir.
And one more important condition, integration from 0 to t sin omega naught mt into sin omega naught nt, and m equals to n. If it is this condition satisfied, then it is actually t by 2. Okay.
Yes, sir.
If m not equals to n, then 0. 0 if m not equals to.
Yes, sir.
And so usually one more type of question what they ask in terms of Fourier series is, like they will give you one signal. Okay, they will give you x of t. Then they will ask you to find a DC signal A0, and also they will ask like other A1, A2 components, and like B1, B2, so on. So these components they will ask you to find. So the formula for finding A0, that is a DC component, is actually 1 by T integration 0 to T G of T dt. Any signal, G of T in the sense like can be X of T also, input signal, any input signal they give you. Like, so you have to integrate over the one period and divide that by the period of the overall period. That we will get as a DC value.
Yes, sir.
Okay. Same way, any AN, okay, it can be A1, A2, A3, anything, 2 by T integration 0 to T G of T, that is input what you feed, into cos omega naught n T dt. Okay, this is for finding an. Same way, and n is not equals to 0, right? Because 0 is actually already it has come from.
Yes, sir. Correct.
Same way, if you want to find the bn, it should be sine instead of cos. Okay, that is a difference.
Yes, sir.
So there is actually shortcut. Shortcut ways for like finding some of the components. Okay, like if they give you some questions, so how to find this a and b and like A0. Okay. So any signal, if it is even signal, you know what is even and odd, right? In the
Yes,
initial.
sir.
If the signal is even signal, then we have to find A0 and AN, but B0 will be straightforward. It is
Yes, sir.
okay. If the signal is odd signal,
Hmm.
this A1, A0 and AN will become 0 straightforward.
Yes, sir.
Bn, so it's not B0, Bn. Okay. Bn will we have to find. What is the Bn then? We have to find.
Yes, sir.
Okay. So this you have to remember. Okay. You can just take a quick example. So they have given one triangular wave.
Hmm.
This way actually. It starts from minus pi. It repeats plus pi and then 2 pi. Then again it is 3 pi. So on. 2 pi. It repeats. And same way in the negative side also it repeats. So is it even signal or odd signal?
Odd signal, sir.
Right. It's a odd signal, right? So if it is odd signal, A0 is 0. AN is
Yes, sir.
also 0. Correct?
Yes, sir.
Straightforward. I mean, I told you one table, right? So then we have to find
Yeah.
only BN. We have to find only BN.
Hmm.
So BN is 2 by t integration 0 to t x of t sine omega naught nt dt. So what is the value of x of t? So from minus pi to plus pi, it is t, correct? Just a t.
Yes, sir.
So actually, if you apply the slope formula, x of t will become, uh, yeah, it is plus v, right? Plus it is minus v. So minus b plus or minus, that one option is there. The slope formula. So if you use that, so you will get like v by pi t. Okay, this is the one what you get. Okay? V by pi t. This is the v by pi t option you get for x of t. So
Yes, sir.
from minus pi to t less than or equals to pi. So if you apply this, bn will become 2 by, now period is actually how much? Minus pi to plus pi. Then repeat. So 2 pi,
Yes, sir.
correct? 2 pi. Period is
Yes,
2 pi.
sir.
So integration from 0 to 2 pi v by pi t. Can you simplify and tell me what is the integration value? V by pi t into, again one more thing we have, right? Sine omega naught nt dt. Hmm.
Mm. I'll tell you, sir. Yes, sir. I'm here.
Yeah. This is a product formula actually. First
Yeah,
term
yes,
and
sir.
second term.
Yes, sir. I know that. I guess it is 2 pi by pi, what is nothing but, yeah, 2 pi by 2 is nothing but 2 and it is minus 0. Mm, So do we get 2 sine omega naught t delta t?
Let me just check simplified expression. Okay. After applying the limits, you are saying?
Yes, sir. After applying the limits, we get v by that is pi into the dash of 2 pi and 0. So if we substitute in the place of v, that is 2 pi by pi, which is 2, and if we substitute 0 by pi, then that yields to some infinity, and we are supposed to get the
So
resultant.
actually, we should the final answer is v by pi n into minus 1 power n plus 1. This is the final expected answer.
Okay, okay.
Quickly, I can show you. So it is actually what 2 by 2 pi will become 1 by pi. Okay. And the product formula is first term into
Yes, sir.
integration of second term, right? Differentiation of second term, right?
Yes, sir. Yes, sir.
Minus then sorry first term into integration of second term minus differentiation of first term, that will become 1 into integration of second term, right?
Yes, sir.
Sin omega naught nt by omega naught n whole square it will become. So you have to simplify this,
Yes, sir.
right?
Yes, sir.
Where did you went wrong actually?
Sir, I guess I did in another methodology, so I guess it went wrong. Right, I just took that integration part, 2 pi integral of 2 pi to 0, that v by pi t sine omega naught of t, the delta t. That part I just simplified, and then I thought of clubbing with this. So there I
Okay.
went wrong basically.
Okay. You just go for that UV rule of integration. Okay.
Yeah, yeah, sure, sir. Okay.
Yeah. Same way you can take it as assignment. So this one you can take.
Yes, sir. Okay.
So it
Sure.
starts from minus pi by 2 till plus pi by 2. This repeats. Okay, so this is
Yes,
pi.
sir.
This is minus pi. Uh,
Yes, sir.
okay. And amplitude is 1 you can take. Okay.
Yes, sir.
So this is actually trigonometric Fourier series, I said, right? So the same way, we have something called an exponential Fourier series.
Yes, sir.
In the exponential Fourier series, we will have something like g of t. Instead of cos and sine, we will represent the signal in terms of exponents. So
Yes, sir.
n equals to minus infinity to plus infinity, cn into e power j omega naught n t.
Yes, sir.
Okay, so in the sense, uh, any signal will be representing in terms of exponents, uh, e power j omega naught t, so 2j omega naught t, 3j omega naught t, so on. So any signal is there, right? So that we will represent with the various levels. So that is the physical meaning of it, significance of it. Okay.
Yes, sir.
So one more thing also sometimes they will ask in the exam. So relationship between trigonometric and exponential Fourier series. So A naught equals to C naught. Both are same. The DC components are same. Okay.
Yes, sir. Yes, sir.
An equals to Cn plus C of minus n, and Bn equals to C of minus n minus C of n. This is the
Yes, sir.
relation. Okay. And expression for Cn, right? It is 1 by t integration from 0 to t g of t into e power minus j n omega naught t.
Yes, sir.
Okay, so this is the expression. So take one problem with respect to exponential Fourier series, then like we can proceed to the Fourier transform.
Sure, sir. Sure.
So the t-axis starts from -1, it goes up to 1. So this is x of t, 0, 1, 2, 3. Okay. And so here, what is the period? T equals to 1, right?
One. Yes, sir.
Yes. So also I have given you expression for finding the Cn. So can you just find exponential for it? Here we have to just find the Cn. So also we have to find from the Cn, we have to find the trigonometric Fourier series. Okay, so this is exponential Fourier series. First you find the exponential Fourier series. Then from there you try to find the trigonometric Fourier series.
Yes, sir.
Yeah. So the expression is 1 by t integration from 0 to t g of t e power minus jn omega naught t dt. So this is the expression for Cn.
Yes, sir.
Can you quickly find Cn for this? So it is actually 1 by, what is t? That is 1, right? So the period is 1.
Yes, sir. Yes, sir.
Integration from 0 to 1, t into e power minus j 2 pi nt dt.
Yes, sir. Correct.
Yeah. Now you can try simplifying this. So again, the integration by part, u into dv.
Yes, sir.
So it says that u into v. So you can say that, I mean, like, or else you can take another way. So this, many people will get confused. U into v, if you have u and v and dt, then u into integration of second term. Okay. So v
Yes, sir.
minus integration of v into differentiation of first term du by dt, right? So now first term is t, correct?
Yes, sir.
T. So t into integration of this. What is the integration of that? E power minus j 2 pi n t by minus j 2 pi n t minus differentiation of first term. What is the differentiation? That is 1. Correct?
Yes, sir. Correct.
And again integration of this. So that will become, again I have to integrate it twice. That is e power minus j 2 pi n t by this will become square, right? So
Yes,
j
sir.
square is minus 1, and minus 1 it will become plus 1, and again minus of square it will be same. So it will become 2 pi n whole square. T won't be there, right? So yeah, 2 is there actually.
Yes, sir.
Then from 0 to 1. So can you simplify this quickly? It should become 1 by 2 pi n. Cn is 1 by 2 pi. Same way C0. What is C0?
Yes, sir.
1 by
1/2. It's one itself.
no, it is actually we have to apply limit formula, right? So it will become
Okay, sir.
actually 1 by 2. Okay.
Okay, sir.
It's actually C0, it is actually j by, not 1 by, so it will become j by 2 pi n. Okay. So C0, the DC component, right? So you have to apply limit formula and you have to find that. So it will become half.
Yes, sir.
Same way, from this actually you have to find an. We have seen that, right? So Cn plus C of minus n by 2 and C of n minus C of minus n by 2 if you make it Dn, right? So this you have to find. You can simplify, take as an.
Yes, sir. I'll take it, sir.
So another important concept in terms of Fourier transform is Dirichlet condition.
Yes, sir.
In terms of competitive exams also, they ask many questions on this. So three conditions are there. So to have the
Yes,
Fourier
sir.
series, right, x of t is actually it is absolutely integrable in the sense whatever you integrate, right, 0 to infinity, 0 to t, 0 to t, integration of x of t dt, it should be less than infinity. Whenever you integrate over a period, it should be less than infinity. That is first condition. So
Yes,
next
sir.
condition, x of t should have finite maxima and minima.
Yes, sir.
In the sense, if I consider this particular signal, so I have one, two maximum and two minimum, right? All the signal, it should have finite maxima and minima. Okay. And number of discontinuities in a signal should be finite. In the sense, if I consider u of t, discontinuity is only at 0, right? 0. Then always 1, correct?
Yes, sir.
U of t. So this discontinuity is finite. So the number of discontinuity should be finite. Okay, these three
Yes, sir.
conditions should satisfy. Okay, but if you consider, for example, x of t is 1 by t, 0 less than t less than 1. So is it absolutely integrable? No, it is
I
not.
guess no, sir.
It is not absolutely integrable,
Yes, sir.
right? It will be not 0 actually. At t equals to 0, it will become infinite, right?
Yes, sir.
Next, if I take something like this, just this one. So this is actually absolutely integrable, finite maxima and minima, and also it has limited number of discontinuities. Correct?
Yes, sir.
What about sin t? Whether sin t satisfies Dirichlet condition?
Yes, sir.
No, because if you keep integrating this sin t, will it valid? No, over a t it's fine, right? Over an entire period, it doesn't have finite maxima and minimum, right? It is actually keep on happening.
Yes, sir.
So it is not integrable. So that's where it is not absolutely integrable. So that's there is like condition doesn't satisfy.
Yes, sir.
Yeah. So next is actually Fourier series properties. Okay.